we'll see a very important property of fluid called as viscosity. Viscosity, and this is the property of fluid which offers resistance to fluid motion. Resistance to fluid motion. And based on this, we can call a fluid as high viscosity or low viscosity fluid. The more the resistance is, the more the viscosity is, and the less the resistance is, the less viscosity. The higher viscosity fluid cannot easily flow because of more resistance there, whereas low viscosity fluid can easily flow. So this basically determines the flow velocity of the liquid. Now this acts between, the viscosity acts between adjacent layers of the fluids. Now let's see this here. Consider we have a fluid, so these are the different layers of the fluid, and this is on a surface here, so this is the surface. Now if I apply some shear force here, say I'm blowing some air which will cause some shear force, and this will drag the layers along this direction. The layers will move along this direction. So you can see the displacement here. I can make a profile here, I can make a curve which will show the different velocities. So you can see the topmost layer has displaced to the maximum extent. Rather, this shows the velocity here. I can write u max for maximum velocity since we have maximum displacement. The bottommost layer, the velocity is equal to 0 since there is no displacement of layer for the bottommost layer. So this bottommost layer is called as the no slip region, or we can call this as boundary region. This is called so because you can see there is no change in position for the bottommost layer, and as a result we call this no slip region. Now there are some forces that is acting between these layers, and the forces, we have cohesive force between these layers. The bottommost layer and the surface, rather we have their adhesive force. Adhesive force, and between the layers we have cohesive force. Cohesive force. Also we have shear stress between the layers. So this shear stress is because of the application of the shear force. We applied some shear force, because of which we are getting the shear stress. Now this cohesive force is accounting for the different velocities, because you can see that as we go up, as the height of the layer increases, the height we can denote as y. As the y increases, the height increases, the cohesive force decreases. So the velocity increases. Whereas when we go down, you can see the velocity is decreasing because the cohesive force is more there. Next is, we'll give a name to this curve here, this profile. I can call this the velocity profile. Velocity profile. Or I can even call this as the strain curve. So the velocity profile, we understood this since this is giving the different velocities for different layers. The strain curve, why we call this as the strain curve? Because you can see that it's also giving the displacement here, the idea for the displacement of the layers. The more velocity refers more displacement. So strain basically means deformation or displacement. So this is giving the idea for the displacement. So the curve, we can also call it as the strain curve. Now we'll see the law which is related to viscosity, and it's called the Newton's law of viscosity. Newton's law of viscosity, which states that the shear stress tau is directly proportional to the velocity gradient, or I'll say rate of shear strain. This rate of shear strain is the velocity gradient, because both have the same profile, velocity gradient. So what is this velocity gradient? Now see here, if I consider the horizontal axis is the velocity axis and the vertical axis is the height of the layers, as y, then we got the profile like this. So these are the velocity lines, So you can see the velocity, rather it will be like this. Alright, so if we have to find the velocity gradient here, we can take any two adjacent layer. Let's take this two adjacent layer. The difference in velocity is du and the difference in height is dy here. So the velocity gradient will be du by dy. So shear stress is directly proportional to du by dy. Shear stress will be equal to mu du by dy, where mu is the proportionality constant called as the coefficient of viscosity.